Good day to my panel and thank you for being here today. I am the Pan Hotline and I am here to do the presentation about my PSM1 proposal. My title is Feature Selection and Classification of Hyperspectral Data for Length Cover Mapping. In my slide, the content is included Chapter 1, Chapter 2, and Chapter 3. For the Chapter 1, it has an introduction, problem statement, aim and objective, scope of study, and last is significant study. And the Chapter 2 is literature review, and last is the Chapter 3, methodology. In the introduction, I will be focusing in the hyperspectral imagery. A hyperspectral sensor has continuous narrow wavelength band about 10 nanometer per inch. They are able to provide the detailed and spectrally continuous spatial information on the length surface. And next is availability in largest amount of bank of hyperspectral dataset around the detailed analysis of the Earth surface. Therefore, hyperspectral imagery has advantages to get an accurate land use and land cover classification, especially in urban area because of the broad spectral resolution and spatial heterogeneity of an urban features. And next, so the hyperspectral imagery, I will obtain it from the PRISMA. So what is the PRISMA? PRISMA is an Earth observation satellite with innovative electro-optical instrumentation, which is it is combined a hyperspectral sensor with a medium resolution panoramic camera. It is one of the platforms to obtain the hyperspectral imagery. So I will obtain the hyperspectral imagery from this PRISMA platform. Next, problem statement. In the problem statement, the hyperspectral imagery consists with abundance of data in contemporary dataset, demand the development of clever algorithm for discovering important information. The statement comes from the Jovi 2050. The high dimensionality of hyperspectral data bring the overhead time-consuming computation, and also the overfitting in the class modeling. And next is abundance of data in hyperspectral imagery may be affect the classification result. Next, therefore, I have an aim and objective in this research. My aim is investigate the feature selection method on classification in hyperspectral remote sense imagery. And my objective have two. The first objective is to test the spectral sensitivity of PRISMA hyperspectral data. And second is to examine the feature extraction algorithm for hyperspectral data. Next, scope of study. My study area are focusing in the Seremban, Malaysia. So why the Seremban, Malaysia has been chosen as my study area? Because of Seremban is a cover with established housing, residential, village, commercial, forest, agriculture, water body, and the infrastructure. In my opinion, I think it is a suitable places to do the classification because it have many classes can be used and can use to classify. Therefore, I choose the Seremban as my study area. Next is scope study. In the first, I will use the satellite hyperspectral data that will obtain from the PRISMA. So after I have obtained the PRISMA, I will do the image classification using the O-band, and second is use the selector band. And I will do the comparison between the both accuracy assessment. Next, Significance of study. Hyperspectral imagery show the availability of largest amount of data, represent a challenges to classification analysis due to use of many features. Therefore, this study can help to identify the feature selection method used to classification in hyperspectral imagery. Next. So in my literature review in the chapter 2, the first hyperspectral imagery has been shown to provide the rich spectral information than multispectral image due to its use of hundreds of continuous spectral bands. The statement comes from the broadcast in JOSH 2030. And next is the high dimensionality of feature space can be linked to the curse of dimensionality, which is known as an ill-posed problem. Because the pattern of closed dimensional feature space are not easily recognized. And this is journal from Jayas and Smell 2010. And next is the classification as an important pattern recognition technique is used to define as a process which convert the data into the meaningful information. And this comes from the journal Maltrap and all 2011. Next, let's continue the literature review. So the accuracy assessment of classification are important for remote sense data. No wonder is hyperspectral data and also the multispectral data. And lastly, the accuracy assessment for remote sense classification actually is a method by which reliability and variability of the result of remote sense classification are quantificationally described. And the statement is come from the Chuan Wu and all 2012. Next, methodology. My methodology is shown as a flowchart, which is divided into the 4 phases, which is data acquisition. The second is pre-processing. Third is processing. And fourth is data analysis. In the data acquisition, I will be use the Prisma image, which obtained it from the Prisma platform, starting from the January 2020. And then my target is only the crowd fit area, especially in the Seremban, Malaysia. So it is important for me to obtain the crowd fit area and also difficult to obtain the crowd fit area. And next is geometry correction in the pre-processing, and then atmospheric correction. Next is MOSFET, and last is subset. After the pre-processing, I will go to the processing. In the processing phase, I will do the 2-step. I will divide into the two step, which is one is do the image classification using the O-band and come up with the accuracy assessment. And next is the feature selection. Feature selection will use, and then image classification will use the selected band and come out with the accuracy assessment. The both of the result of accuracy assessment will be used to do the comparison in the data analysis. Next is data acquisition. In here, I will briefing more detail about the data acquisition. The satellite hyperspectral data will be obtained from the Prisma platform. And in the Prisma platform, I will select the crowd fit area. In the figures above, in the slide, has shown the Seremban, Malaysia with crowd free. And we can clearly to view that it have a residential, water body, open space agriculture, and infrastructure. So based on this image, I can use it to do the classification and so on. Next is data pre-processing. In data pre-processing, the first step I will do is the geometric correction. So what is the geometric correction? I will use the geometric correction can be used to remove the geometry distortion for the hyperspectral imagery. And next, I will do the radiometric correction and use to avoid the radiometric error or the radiometric distortion for the hyperspectral imagery. Therefore, I will use the two output from the two correction to do the MOSFET. And then I will go to the subset, which is I will select only the specific area from the hyperspectral image obtained from the Prisma. Select the specific area that easily to me to do the classification. Next is data processing. Data processing have divided in the two phases, which means in the first phase is use the image classification using all band to do the classification, and it will come out with the accuracy assessment. Second, I will use the feature selection method to select the useful band mean, which is it can bring the benefit to the classification result. And then I will using the selected band to do the image classification. In here, I will also use different classification algorithm, especially in the spectral angle mapper and the support vector machine to do the classification. So the accuracy assessment have a differences result come from the different classification algorithm. Next, so in the data analysis, I will use the accuracy assessment in the phase 1 and also the accuracy assessment in the phase 2 to do the comparison to view that which is suitable or which is the best classification result showed in the mapping. Next is the expected result. From the figures, we can view that the classes have many classes have been classified. For example, the healthy grass, straight grass, artificial tusk, and so on. So my expected result is my Seremban area will have a differences classes also combined with the overall accuracy as shown in the figures in the right hand side overall accuracy. So we can, as a user, we can view the differences for the classes changes and also for the overall accuracy to view the exactly the accuracy of the output. That is my expected result. Next, in this page is the research planning and schedule Gantt chart. In this Gantt chart, I have a planning in the preliminary study, topic selection, synopsis of proposal, submission of proposal synopsis is planned in and submit it in the October 2020. Also, and next is the review of chapter 1. I plan and submitted the review in the chapter 1 is on the November 2020. And follow up with the literature review of the proposal chapter 2, discussion of methodology of proposal chapter 3, expected result, review of the proposal. I'm planning it from the November until December 2020. So for the next is the submission of the proposal. And last is the presentation of the proposal. The date and the date in the time is fixed in the January 2021. So we have to do the submission and presentation of the proposal in the January 2021. And next is a data collection and statistical analysis. I plan to collect the data from the Prisma platform to obtain the hyperspectral data is from the November 2020 until February 2021. So based on the timeline, I will collect and try my best to get the data which is in CloudFree for the Seremban Malaysia. And next is the analysis and evaluation. I plan to do the analysis and evaluation in the April 2021 until June 2021. And second last is the project presentation. I expected the project presentation may be located in the July 2021. And last is the writing up. The writing up, I have used to write the thesis is starting from the October 2020 until the 2021 July. That is my Gantt chart overall. And next, I think that's all from me for the proposal presentation. Thank you for your listening. Thank you.